The beginning of 20th century, it was thought by astronomers that the universe is stationary and has no motion over large distances. This caused Albert Einstein to interpret a stationary universe by adding the cosmological constant term lambda to his general relativity relation. This lasted not much long that Edwin Hubble showed the expansion of the universe through the red-shifting phenomenon. This discovery caused the term lambda to be omitted for a while, but there were many others who tried to interpret redshifting in a way to be consistent with a static universe. Even Edwin Hubble himself later on turned against the universe expansion interpretation of redshifting and was more convinced with a static cosmos. But the theory of Big Bang and universe expansion continued to find their way. So it was thought that the expansion must be decelerating under the force of gravity. To check the exact value of deceleration, two groups of astronomers separately tried to find the deceleration rate in 1990s. After observations and analysis of the data from supernova type 1a, they concluded a very weird result. The universe expansion is not decelerating, but rather it is accelerating. This revolution invoked the presence of cosmological constant once again, but for a different mission, the universe acceleration. Since then, the observations have continuously confirmed the acceleration of the expansion. The lambda CDM model is the best model fitting the observation of data and acceleration of the expansion. Cosmological constant is the cause of the acceleration in this model and is measured to contain about 70% of the universe density. According to Einstein and its general relativity, empty space is not completely empty, but it is made of woven fabrics of space and time. It is assumed that the energy of the fabric of space is acting as a repulsive force and expands itself. In the same time, according to general relativity, gravity is the curvature of the fabric of space and time that is caused by the presence of matter. Cosmological principle is one of the fundamental assumptions in general relativity and the cosmological constant application. According to this assumption, the universe is both isotropic and homogeneous over large distances. But as the observational instruments improve day by day and astronomers can see deeper through space, they discover larger and larger structures and walls, such that these large structures are going to threaten the cosmological principle. There is a lot to discuss on whether the universe is homogeneous and isotropic or not, but mostly cosmological constant is going to be confirmed or interpreted in a way to have consistency with observations. So I am not going to discuss on this title since we are sure that the universe is not uniform. By uniformity, I mean that all those masses that are receding from one another, for example clusters and superclusters, must have the same mass and the same distance from one another. But as we know, this is not the case. There are structures that cover over billions of light years, like the GRB wall, and voids that cover more than 400 megaparsecs. This non-uniformity of mass distribution would allow me to analyze the universe expansion by vacuum energy in such a way that lambda CDM model would be disproved, and there won't be any room for cosmological constant or metric expansion of the universe. According to the latest discoveries, universe is dominated by dark energy, such that close to 70% of the universe density is dark energy and about 30% is matter. The curvature of the universe is measured to be very close to zero, a flat universe, and the expansion rate is measured to be about 67 kilometers per second per megaparsec. The universe expansion according to lambda CDM model is a metric expansion, not a movement or departure of galaxies with respect to space, such that the fabric of space itself is going to be stretched and grow by itself. The amount of vacuum energy or cosmological constant in every unit of space is thought to be non-zero but very small, about 10 to minus 9 joules per cubic meter. Based on the above-mentioned points, I want to explain why a cosmological constant can't be the cause for the universe expansion. According to general relativity, the lines of the fabric of space-time are straight in general, but wherever there is mass, these straight lines would be distorted and curved around the mass. So gravity is the curvature of the fabric of space around the mass. The first thing we can conclude is that the fabric of space cannot expand at locations where there are masses or massive objects, but rather it warps inward. In general relativity, this phenomenon is described as frame dragging, where massive objects drag the fabric of space and warp it inward as massive objects like black holes and even Earth do it. So wherever there is a mass that can prevent the expansion of the fabric of space on that point, we contract that point as a lock, such that at least there is no expansion. To realize that matter distribution through space will affect the metric expansion of the universe, let's consider Figure 2. Figure 2 indicates a uniform universe, where all masses and distances between them are the same. The metric expansion of space by a cosmological constant vacuum energy is possible in such a case, where space cannot expand inside the squares, but it expands freely between the squares and parallel lines at x and y directions. So there is no lock against the metric expansion of the universe. But we know that such a universe is an ideal one, where observations do not confirm it. Now let's bring a small change to Figure 2 and add a mass at point A. By locating a large mass at point A, we prevent the expansion of space there. So new space won't be created at point A, and masses C, D, E, and F would be stacked together. At the same time, on the opposite of A, there is point B, where there is no mass, and so new space will be created, and masses G, H, I, and J will move apart from one another. But there would be a problem. In the case of creating new space at point B, we must move all the masses along point B relative to the masses along point A. So to do this, there must be a repulsive energy to overcome the gravitational pull between all masses along A and B. And this energy must be provided by the fabric of space at point B. Point B had such a repulsive energy to overcome all of those gravitational pulls, then of course it could tear apart the gravitational bonds between the masses inside a galaxy, and even maybe it would be able to tear apart every single atom. In Figure 4, I tried to demonstrate two parallel lines of matter distribution such that they are consistent with homogeneous and isotropic universes, because in every line there is the same number of masses and voids, but the matter distribution along x direction is not uniform, where the masses and distances between them are not equal and the same. In this figure, the total number of masses in every line is 11, and the number of voids is 8 units. As every unit of voids expands, it will add 1 unit of velocity to the following masses in x direction. To realize the relative movement of one part of the universe relative to the other part, I compared the velocity of adjacent masses in both lines. F1 and E2, or A and B, are the adjacent masses with different velocities. It indicates that as the space expands in voids like between B2 and C2, this void must have a repulsive energy not only to overcome the gravitational pull between B2 and C2, but also it must be able to overcome the gravitational pull between adjacent masses moving relative to each other due to space expansion between B2 and C2. So if we consider one portion of space billions of light years, there would be millions or billions of adjacent masses that will move relative to one another. Then only 1 unit of space, for example 1 unit of space in the void between B2 and C2, must have that much repulsive force to overcome the gravitational pull between billions or even infinite adjacent masses that move relative to each other due to space expansion between B2 and C2. This clarifies that the expansion of space with a cosmological constant is demanding an extremely high value of repulsive force in every unit of space, which is not compatible with the proposed value of 10 to the minus 9 joules per cubic meter. It might seem something like vacuum catastrophe, where the proposed value from observations has a coefficient difference of 10 to 120 orders of magnitude with the theoretical value, but the predicted value of the cosmological constant by theory is not going to be consistent with the universe. It will tear apart everything just in one moment. Our analysis shows that a cosmological constant vacuum energy will not expand the fabric of space because of the locks due to non-uniformity of mass distribution in the universe, or it will be possible with a relative movement of masses across the universe. Relative movement of one portion of the universe with respect to the other portion in turn would demand an extremely large value of repulsive force in every unit of space, like the theoretical value of cosmological constant, or even bigger than that. Once again, such an extremely high value of repulsive vacuum energy would tear apart every single atom in the universe. So there is no room for cosmological constant metric expansion of the universe and lambda CDM model. It is mentionable that Figure 4 is not only rejecting and disproving the cosmological constant or lambda CDM model, but also it will disprove most of the theories that are proposed for the universe accelerating expansion by the scientists. It actually works like a test machine for the proposed theories, and most of them will fail this test. I claim that any theory proposed by scientists to explain the accelerating expansion of the universe would be wrong, and I am ready to disprove them. But what is my own theory for the accelerating expansion of the universe would be a theory that is completely compatible with the Quranic verses, and I will explain it in another video under the title of Heaven is the Cause for the Universe Expansion.